Dr. M.C. Sundaraja. He completed his undergraduate studies from Madurai Kamaraj University and went on to complete his master's in structural engineering from the same. He is a doctorate from Anna University and he's also done his postdoctoral fellowship at the Queensland University of Technology, Australia. He has more than 17 years of experience in the teaching profession and he has also published papers in 39 international journals, 7 national journals, 27 international conferences and 51 national conferences. He has so far published 124 papers in various journals. He went on to receive the Best Research Paper Award from IFERP, a unit of VVERT and NIRE on 4th April 2015. He has also received Outstanding Faculty Award from the Venus International Foundation Faculty Award, VIFFA, in the year 2015. Currently, Dr. M.C. Sundaraja is now working as an assistant professor in Tyagarajar College of Engineering, Madurai.
Welcome to the UGC lecture series in B architecture. In the previous lecture, we have seen in detail about how to find out the moment coefficients for two-way simply supported slab and two-way restrained slab, and also how to find out the bending moment for one-way simply supported slab. And also we have seen in detail about how the design guidelines requirement for the design of slab as per IS 456-2000, that is starting from effective span of the slab and the total load which is acting on the slab and the moment, then arrangement of reinforcement, that is what is the maximum spacing of reinforcement, what is the maximum diameter of the bar, that we have seen in detail in the previous lecture. In this lecture, here also we are going to see in detail about the arrangement of reinforcement for one-way slab, two-way slab as well as one-way continuous slab. This is one-way simply supported slab and two-way simply supported or two-way restrained slabs, and also one-way continuous slab. And how to provide the reinforcement detailing for this slab? The reinforcement detailing normally based on its behavior only, when it is subjected to the kind of forces. So, here for example, in the case of a simply supported slab, this is a simply supported slab, you take it as if it is resting on a wall at the ends, when it is subjected to some kind of forces, this is W kilonewton per meter square. When it is acting on, when it is subjected to some kind of forces, it is deflected like this. Normally, in the case of RCC structure, the provision of reinforcement depends on deflection nature of the elements, RCC structures. First, we must know how the structure or elements will be deflected, and based on that we can easily identify the location where the tension is developed. Normally, in the case of RCC, the concrete is very strong in compression. In the compression portion, we are going to provide the concrete, and in the case of tension portion, we are going to provide tensile reinforcement. That is, we need to identify where the tensile stress is developed. So, how the tensile stress can be developed, how to identify it based on its deflection criteria. So, this is an example of a simply supported slab. This is a deflection nature of a simply supported slab. So, here in the case of simply supported slab, the deflection is it's a deflection nature of the beam. So, from the deflections, the tension is developed at the bottom. In order to resist the tensile stress at the bottom, the reinforcement has to be provided at the bottom. So, here this is the plan view, this is the support, you take this as a support and this is the slab portion. The reinforcement normally has to be adopted like this. This is the arrangement of reinforcement in the case of a pure simply supported slab. Okay. And this is the bottom reinforcement. So, after finding out the reinforcement, we are going to find out the max spacing between the reinforcement. This is the arrangement of reinforcement. This is called as main reinforcement. This reinforcement has to be properly placed with a proper spacing. In order to place or in order to keep the proper spacing of the reinforcement, a reinforcement should be provided in the perpendicular direction that reinforcement which is used to distribute the main reinforcement with the proper spacing. That reinforcement is called as, that is the perpendicular reinforcement is called as a distribution reinforcement. This is a distribution reinforcement which not only to distribute the main reinforcement with the proper spacing, it is also to avoid the cracks which is developed due to shrinkage and the temperature variation. This is normally developed in the long term. So, this is the arrangement of reinforcement in the case of a pure simply supported slab. Now, if the next second case, this is simply supported slab. I am telling that there is some example of pure simply supported slab. There is a slab which is provided over the septic tank or the water tank which is constructed in the residential building, that is freely resting on the wall. That is an example of pure simply supported slab. Other than this, there is no pure simply supported slab in the construction of building or any buildings, understand. So, normally we are constructing a wall over the slab, but what will happen in the case of simply supported slab when you construct the wall over it or the slab is built into the wall. So, here we are having the wall over it. If it is a one way simply supported slab, it is one way slab. This is also one way slab. So, here L y by L x is greater than 2. In the case of this slab, here this is the bending nature of the slab, is correct. When it is built into the wall, the portion over the support will be deflected upwards, the portion between the support will be deflected downwards. This is the positive moment, this is a negative moment. And how to find out this negative moment? We can't find out. This is a partial restraint which is developed over the support when you construct the wall over the support in the case of slab. So, here we know the bending moment at this place, this is W H square by 8. Now, how to provide the reinforcement in this case? This is support. And this is the plan view. You take this as the support and this is the support. This is the plan view. This is the portion of the slab. So, here as per IS code, when you provide the reinforcement at the bottom, the 50% of the reinforcement which has been provided at the bottom has to be cranked near the support and bring it to the top to resist this tension. This one which has to be 0.1 L from the face of the support. The 50% of the reinforcement has to be cranked at a distance 0.1 L from the face of the support and bring it to the top. This is called as the main reinforcement which has to be again provided at the top as well as at the bottom. And how this can be drawn in the case, this is the top reinforcement I have drawn using dotted line and the bottom reinforcement has been drawn using continuous line. This is a crank bar and this one is the another bar, straight bar, and this one is another cranked bar and this one is another straight bar. So, it means that alternate bar has to be cranked over the support to resist the tension which is developed at the top. It has to be cranked at 0.1 L from the face of the support, and in order to keep this main reinforcement in one direction, that is one way slab, there is the reinforcement which is provided in the perpendicular direction. That reinforcement is called as distribution reinforcement. So, here in order to resist the partial restraint over the support, IS code says that only 50% is more than enough to resist the partial restraint which is developed over the support. That 50% the reinforcement has to be provided over the support. It is by means of cranking the main reinforcement over the support at 0.1 L from the face of the support and bring it to the top. This is more than sufficient for resisting this torsion. This not torsion, this is the tension at the top. So, this is the arrangement of reinforcement in the case of one way simply supported slab, one way simply supported slab. this is also simply supported slab. Now, in the case of two-way slab, so here this is a two-way slab, this is a two-way simply supported slab. Okay. So, here also in the case of two-way simply supported slab, here Ly by Lx is less than or equal to 2. This is two-way simply supported slab. In this case also, here if it is a pure simply supported slab, if the wall is not going to be constructed over the slab, the main reinforcement has to be provided along both the direction in the form of mesh. That is called as mesh form of reinforcement. So, I will show it in the plan view. It is something like this is the wall and this is a portion. So, the reinforcement normally we are providing at the bottom along both the direction as the main reinforcement. That is called as the mesh arrangement of mesh form of reinforcement, that is all. Both the reinforcements are called as the main reinforcement. Since Ly by Lx is less than or equal to 2, there is a bending along both the direction. We need to find the bending moment along both the direction. We need to find the moment along that, we need to find the reinforcement along both the direction. Those two reinforcements are main reinforcement. This is pure simply supported slab. Now, if this two-way slab is built into the wall. So, for example, if the wall is going to be constructed above the slab, here this slab is also bent like this. In order to resist this deflection over the support, the 50% of the reinforcement has to be cranked near the support at a distance 0.1 L from the face of the support and to bring it to the top. And this is the cranking of reinforcement. So, here if it is Lx, this is in Lx direction. If it is another direction, this will be Ly. In another direction, it is Ly, 0.1 Ly. So, here the alternate bar has to be cranked over the support and other bars are straight bars. And this bars is also called as the main reinforcement in another direction. So, here in the plan view, this is a support. So, here this is the arrangement of the reinforcement. This is another bar, straight bar, and this one is the cranked bar, and here you are having the wall. You assume that here we are having the wall. This is the straight bar. In this direction also we need to provide the main reinforcement. Here also the main reinforcement has to be cranked over the support at 0.1 L from the face of the support. So, alternate bar has to be cranked over the support along both the direction and bring it to the top to resist the tension over the support along both the direction. This is in the case of two-way slabs. If the two-way simply two-way, that is the restraint slab. So, if you are having the wall on a board. If it is a pure simply supported slab, there is no need to provide the reinforcement at the top. The reinforcement has to be provided along both the direction as a main reinforcement in the form of mesh. But here, if the wall is built into the wall, if it is a restraint slab, we need to have the tension at the top over the support. We need to provide the reinforcement at the top. So, here in order to resist that moment over the support, the 50% the main reinforcement has to be cranked over the support at 0.1 L from the face of the support and bring it to the top along both the direction. If it is in the one direction, that is called one way simply supported slab. Now, next one is, in addition to this reinforcement in the case of two-way slab, if it is a pure simply supported slab, normally the case of two-way simply supported slab which do not have any adequate provision to resist the torsion at the corners, it will be lifted up. In order to prevent the lifting up of the slab portion at the corners, we must provide a separate reinforcement over the corners, both top as well as at the bottom, at the form of mesh. Top there are 2 layers, bottom there are 2 layers. Now, to calculate the reinforcement required for it, Once you find out the AST required for the reinforcement, the corner reinforcement, that is the torsion reinforcement, which has to be provided for a length of L by phi. If it is x direction, it is Lx by phi. If it is y direction, it will be Ly by phi. And what is the reinforcement? What is the total area of reinforcement required to resist the torsion at the corners? That is 3/4 of AST required. Total AST required for resist the bending moment, that is from this 3/4 of the reinforcement has to be provided separately to resist the torsion at 4 corners in the case of 2 simply supported slab, which do not have any adequate provision to resist the torsion at the corners. This must be provided for a length of Ly by phi or Lxy by from x and as well as y direction respectively in the form of mesh both top as well as at the bottom. That is the arrangement of the reinforcement in the case of 2-way slab. This is the, and this I have already told you, this is a corner reinforcement, that is the torsion reinforcement at the corners. It has to be provided Lx by phi or Ly by phi. And another one is the continuous slab. In the case of continuous slab, one-way continuous slab. So, here this is the one-way continuous slab. It has one, two, three, 4. This is 4 span one-way continuous slab. And how to provide the reinforcement in this case? I already told you that the reinforcement has to be provided depending upon the deflection nature of the structure. Now, when it is subjected to some kind of forces, this is the slab which is deflected like this. If this slab is not built into the wall at the end support, if you are going to have any wall, this slab will be deflected upwards. If you are going to construct any wall over the end support, it will deflect upward like this. We must provide the reinforcement at the top in the end support. So, here in between the two supports, the portion will be deflected downwards and the tension is developed at the bottom. So, we must provide the reinforcement at the bottom. At this over the support, it is deflected upwards, we need to provide the reinforcement to resist the tension at the respective places. And how to provide this reinforcement in the case of this one-way continuous slab to resist that deflection. This is as per IS 456/2000. So, here this is the 50% of the reinforcement has to be provided as the straight bar. Another 50% of the reinforcement has to be cranked over the support and bring it to the top to resist the tension which is developed at the support, that is at the top. So, here in the case of this continuous slab, we have found 4 bending moments and 4 places, that is there are 2 moments on the span and 2 moments at this over the supports. One is the moment at the end span, at the middle of end span. Another one is the moment at the other interior span. In the case of support moment, we are finding the moment at the support next to the end support. These 2 supports are end support, the support next to the end support, and this support is called as interior support. Among 4 bending moments, in the case of slab, we are selecting the maximum bending moment for designing the thickness of the slab as well as the reinforcement required for it. It is not like in the case of continuous beam, but in the case of continuous beam, we are finding the thickness of the slab against maximum bending moment, but the reinforcement separately calculated for all 4 bending moments. But in the case of continuous slab, both the thickness of the slab as well as the reinforcement has to be designed against the maximum bending moment only. Since when you design the reinforcement separately for all the 4 bending moment, there will be a chance of conjunction of reinforcement. In order to avoid that conjunction of reinforcement or overlapping of reinforcement one with another, so we can't provide the concrete over the reinforcement. To avoid this, we are normally design the reinforcement against the maximum reinforcement. About which moment will be normally maximum among 4 bending moments? There is a moment which is found at the support next to the end support is always maximum, since the moment coefficients are like that. So, here in order to here, here we have provided 100% of reinforcement at the mid span. So, here alternate bars are cranked over the support, but in the mid span we have provided 100%, but in at the over the support we have provided only 50% of the reinforcement. In order to satisfy another 50%, a separate reinforcement has to be provided at all interior supports. This reinforcement has the length of reinforcement should be 0.3 L on either side of the face of the support. There is a separate reinforcement, that is a separate reinforcement, that is a extra reinforcement which has to be provided exactly over the bottom straight bars at the top. It has to be provided at the top exactly opposite to the bottom straight bars. Bottom straight bars, that is just above the bottom straight bars at the top. So, here the length of reinforcement, the total length of reinforcement is 0.3 L on either side of the face of the support plus the thickness of the support. So, here also it is 0.3 L on either side of the face of the support, but we are not normally providing the extra reinforcement at the end support, since there is a partial restraint which is developed over this support. Here to resist that partial restraint we can provide only 50% of the reinforcement, that is more than enough for resisting the moment at the end support. So, the moment which is normally developed is W h square by 24, it is very less when compared to the moment at all other 4 places. That is why there is only 50% reinforcement can be provided, that is more than enough for resisting this bending moment. No need to provide the extra reinforcement over the supports at the end supports. So, then in order to provide or keep the main reinforcement with the proper spacing, there is a reinforcement in the other direction, that is a perpendicular direction. That reinforcement is called as the distribution reinforcement. This is a reinforcement which is not only to distribute the main reinforcement with the proper spacing, it is also to resist the cracks to the develops due to the shrinkage and temperature or creep of concrete in long term. So, this is the minimum reinforcement distribution reinforcement, since it is one way simply supported slab, it is spanned along only one direction. In the case of two way slab, there is a continuous two way slabs also there. In that one, the main reinforcement has to be provided along both the directions for the respective bending moment on the respective direction. So, this is the one arrangement of reinforcement for one way continuous slab. This is one way continuous slab. These are all the arrangement of reinforcement as per IS 456. So, here I am reading that classes. Slabs are considered as normally divided in each direction into middle and end strips. Middle and end strip. Middle means at the mid span, end strip means at the end portion of the slabs. The maximum moments obtained using the equations are applied only to the middle strip. 50% of tension reinforcement provided at the mid span in the middle strip shall extend in the lower part of the slab. In the case of continuous slab, this reinforcement has to be cranked 0.25 L from the center of the support. That is, this has to be cranked at 0.25 L on either side of the center of the support and bring it to the top. But at the edge one, it has to be cranked at 0.15 L from the center of the support. This is given in the IS 456 2000. 50% tension reinforcement the midspan, the middle strip shall extend the lower part of the slab within 0.25 L of the continuous edge, that is over the interior supports, and 0.15 L of the end discontinuous edge, that is at the end support, and the remaining 50% shall extend into the support. 50% tension reinforcement at the top of continuous edge shall be extended for a distance of 0.15 L on each side of the support. That is, it means that the reinforcement which has been cranked at 0.25 L and it has been brought into the top, it has to be extended at the top for a distance of 0.15 L. That is, the IS code specify that. on each side of from the face of the support, and at least 50% shall be provided for a distance of 0.3 L on each face of the support, on each face from the support, that is we have provided. Another 50% has to be provided on for a distance of 0.3 L from the face of the support. Total length of this reinforcement is 0.3 L plus thickness of the support plus 0.3 L. At discontinuous edge, negative moment may arise. In general, 50% the mid-span steel shall be extended into the span for a distance of 0.1 L, not 0.5 L, 0.1 L at the top. Here at the discontinuous, it has to be cranked at 0.15 L and bring it to the top for a distance of 0.1 L over the end supports. That is 50% reinforcement has been more than enough for resisting the tension at the end support only. Minimum steel can be provided in the edge strip. The tension steel shall be provided in the corner in the form of grit in two directions, the top and bottom of the slab, where the slab is discontinuous at both the edges. This area of steel in each layer in each direction shall be equal to 3/4 of the area required for maximum mid-span moment, and this steel shall extend from the edges for a distance of Lx by y. This is a torsion reinforcement of the corners. The area of steel shall be reduced to half 3/8 As at the corners containing edges where only one edge is continuous and other edge is discontinuous. In some cases, one edge continuous and other edge is discontinuous. At that corner, half of the reinforcement has to be provided at the corners to arrest that lifting above the corners when one edge is continuous and other edge is discontinuous. So, this is the detailing of reinforcement as per SP 34. I have explained in detail. This is the arrangement of reinforcement for two-way slab. This is the arrangement of reinforcement for one-way slab. This is two-way slab. This is a reinforcement required for the corner bars. Now, we come to the end of this schedule. I summarize. In this lecture, we have seen the behavior of one-way and two-way slab. In this case, we have seen the arrangement of detailing of reinforcement as per IS 456-2000 as well as SP 34 for one-way and two-way slab as well as one-way continuous slab. With regard to the questions for this lecture, give the IS codal provisions for the detailing of reinforcement in slab. We must know how to draw the reinforcement. This is most important. Knowing of design of slabs is not only most important. We need to represent the design in terms of the drawing. We must know the detailing of reinforcement as per IS 456 as well as SP 34. So, we must know the drawing of the reinforcement, that is draw the longitudinal reinforcement of one-way and two-way slabs which shows the reinforcement details. In connection with the references, we need to follow the IS 456-2000 as well as IS 875. IS 875 which is used to calculate the design loads for the buildings and structures, and IS and then another special publication, that is SP 34, which is necessary to know the detailing of reinforcement required for the various members in the case of RCC structures. And in the case of books, I am following S.N. Sinha, that is Reinforced Concrete designed by Dr. McGraw-Hill Publishing Company Limited. Then another book which was written by Ashok K. Jain, that is Reinforced Concrete, a limit state design. Thank you very much.